Rohtla. I'm from Estonian Marine Institute, University of Tartu, and I'm gonna present you guys some of the results we have so far gained from our telemetry studies in the Western Estonian archipelago sea area. And yeah, the final goal of all of these studies has always been to propose a restoration project for the specific spawning area under study. So first, to give you some background, so far I haven't noticed too many nice pictures of the study species. So I'm going to take this moment to actually introduce you the study species. So this is a pike. This is where we are located. It's in the eastern Baltic Sea. And if you zoom in, you can see that it's in this Western Estonian archipelago area, which is the hot zone of coastal pike in Estonia. Like, we don't have much pike in the northern coast or in the southern areas of Estonia. So most pike inhabit this really nice Western Estonian zone. And to continue with some background and contexts, pike is commercially and recreationally really important in Western Estonia. So far, the commercial catches have been highly variable. Lately, we have been seeing this really nice increase in our area. From like 8 tons in 2007 to almost 50 tons in recent years. But however, we do have a huge issue with these fluctuating stocks. So, and we think mainly that it's mainly due to overfishing, because there is too much passive fishing rights out there. So the fishermen fish only when there is fish. They don't fish when the fish numbers are down. So, and if the numbers go up, the prevailing stock is overfished quite rapidly. Freshwater spawning strongly dominates, as it has been referred to here before. This is presented more thoroughly later by Roland, and yeah, introducing the automated microchemistry analysis we have done. And from those analyses, yeah, we know that we only have few known freshwater spawning sites in our study area. And from the literature, we know that it might have been more in the past, but yeah, it's gray literature, so we are not that sure about that. But of course, the fishermen today, they even tell you today that the brackish water spawning pike is abundant as we speak. So yeah, just jumping to the studies. First, the study using the pit telemetry in some of the seasonal lakes we have in our coastal sea. So here you see the seasonal lake, which are not that large. So if you zoom in, we have 2 lakes, which are mainly filled up with water in spring or in late fall, but it's mainly driven by precipitation. So it's rainwater or snow melt water in spring that fills up these lakes really nicely. And yeah, and anadromous pike from the Baltic Sea make their way into the spawning area, the wetland, and spawn there. So these lakes have only one main outlet, and there were actually more before, but as this area is already restored in a sense, so right now it should only have one main outlet, but in the past it had more. So this area is actually also heavily grazed by cattle, so this also creates these really nice habitats for spawning pike. So this is the main outlet. It used to be like this. So we had this boulder dam, which is actually a really like an old 16th, 17th century road built by the people, and yeah, and it serves like a dam for the spawning area. So it It will enable the pike to enter the wetland, but it will also create this wetland and create this nice habitat. And here you can see also the pipes which were placed in by the environmental agencies just to facilitate the migration of spawning pike. So this is how it looks from the air. You see it's a really nice area, and the water levels highly fluctuate depending on the spring. If we have a lot of snow, we can have like a small sea in here, and it's all on grazed grassland, so meaning that it's a really nice spawning habitat. The problem, however, is that the water will flow away quite rapidly, especially during lately, since we haven't been having these really good winters, in a sense that the snow will usually melt already in February or early March. So there isn't enough water coming into the wetland to sustain the water level. So the water will drain up, and the result is that most of the eggs that are spawned will probably perish. Most larvae that are enabled to hatch will probably perish or not get out, and probably also some adult spawners will not get out. So in summary, this is lost potential. And yeah, we end up with these really small pools where the fish are stranded, and heavy cannibalism happens there. And that was the situation before we started our study. So in our study, the main aim was to first assess the movements of adult pike on the wetland, and also keep some estimations on survival in the wetland and also later in the sea. So we tagged pike in 3 consecutive years with pit tags. We used this nice wetland pike net, and we deployed pit antenna to different parts of the study area. So this is the main entrance, the main area where the fish enter from the sea and also exit. So we had antennas here, and we also had antennas in between the 2 lakes on the culvert below this road, to study how many pike actually go into the upper lake to spawn. So here are some of the results about adult spawners. We saw that the average time spent at spawning ground was 16 days, but of course it varied between 1 to 55 days. Females, as expected, were the fastest. Some of them spawned within 1 day. And then again, the males, as expected, stayed on the spawning ground the longest. The majority of the pike actually stayed and probably spawned in the first or the lowermost lake. And only 1/5 of them actually migrated to the upper lake, which is actually less in coverage, less in size, but it's also less grazed. So this might be also a problem for the pike. If it's like heavily vegetated, there isn't that much available spawning area there. We also made a rough estimate on spawning ground survival, as we know that heavy poaching is happening on the spawning ground. So poaching is actually a big problem in Estonia still. It's not a thing of the past, it's a current thing. And yeah, it's mainly in spring in pike and in autumn for spawning sea trout and salmon. So yeah, it's a big thing in Estonia for some reason. And yeah, so we estimated survival on spawning ground, and based on our taggings and our pit telemetry data, we estimated that actually almost half of the pike are lost during the spawning, whether it's because of the poaching or whether it's natural mortality, because also some birds are fishing for pike there. And we also provided a rough estimate for sea survival, which was also almost 50%. Meaning that, yeah, probably heavy fishing pressure, as we know, yeah, as I mentioned, commercial fishing, recreational fishing, and also seals. We have many seals just in the archipelago sea area. So yeah, this might be the probable causes of also quite high sea mortality. Regarding the young of the year immigrants, we were also interested in that, to see how many juvenile pike actually descend the wetland in spring in the same year when we had actually counted the adult spawners. So we had this device on the wetland to count them and eventually estimate the numbers. In the first year, or actually in the second year when we did it, we estimated that about 5,300 fry actually descended the wetland. And this was a pretty high adult spawner year also. We had almost 500 spawners, roughly like 250 females and yeah, the same amount of males. But the interesting thing was that for that year, that actually more than half of them actually descended the wetland after the connection with the sea was lost on May the 17th. So they didn't reach the sea and probably perished. In the second year, completely different year. This year we only tagged or caught approximately 100 pike, and later on only 75 were observed descending the wetland, which is really low. And this also exemplifies the huge problem we have in the wetlands and a really high fluctuation in the success of spawning each year, which is heavily dependent on the water levels in spring. So yeah, these were the main results we were after, and we used these results to propose a restoration plan together with engineers. And this is the result now. We made the stone dam more waterproof, so that the water will not drain throughout through the dam. We also constructed a fishway, but perhaps most importantly, we constructed this dam which can be regulated, so we can keep the water level up during the most critical times. And if it's too much water, then we can just remove some of the boards in the dam just to reduce the water level. So it's manual, but still it's the best solution. And since we have a local guy living just next to this site, so it's quite easily managed. And we plan to actually estimate the success of this activity starting from next spring. So this is it for the first study. For the second study site, we have the river Kasari Delta estuary, which has actually the same problem, but this is on a larger scale. So for this study, we just move around the corner to this area here, where we have the Kasari River, which is the main river, and all the different rivers actually that also run into the bay. And all this creates this really nice delta estuary. And in the spring, we have these really nice floods, creating these wetlands where actually the spring spawners can spawn. But the problem is that, as you can see from the picture, that many of the streams or rivers are straight. This is because in the early 20th century, the river or the system was heavily canalized and dredged by these things. And now we have these straight canals. It used to be quite more complex, more mosaic. We had like many more canals, and of course back then the winters were longer and the floods lasted longer. But now it's just not the case anymore. So, for example, in March we could have this. This is a picture from a wetland between these river canals. You can have this really nice spawning habitat once again, like hectares and hectares of quality spawning area. Really nice. But after a few weeks, this all changes. So the water goes away, and we only have some small pools left. So yeah, this is quite sad actually. And here you can actually see one of the hydrophones we deployed onto this wetland. So yeah, here we tagged pike with acoustic tags. We deployed receivers to different sections in the rivers and also on the wetland. These receivers here. We tagged pike in the inner bay area and in spring, and we also had hydrophones in these regulators, which have been constructed to flood the wetland and keep the water levels up, but they don't work that much, but they do create this high current, which might stop pike migration, for example. So yeah, we deployed hydrophones also there. So some of the results, the main results we were interested in was to see whether the pike use the rivers or whether they spawn in the wetlands or in the inner bay area. So in the first year, we saw that actually 28% of the pike only ascended to rivers, and large majority of them actually went straight to the wetland or spawned just in the inner bay area. In the second year, pretty much the same results. Only a small amount of pike entered the rivers, and most of them actually stayed in the inner bay area or went to the wetland through the weed belt. So to check this different questions we had, we deployed hydrophones to these wetlands to see if the pike actually migrate through this really dense area of weed belt, which is actually also covered by the water, so it shouldn't be a problem for the fish, or they actually like stay in this area. So judging from the receiver data, we didn't see any detections in these wetlands. So this probably means that most of the pike in this area, in our study area, spawn in this inner bay area here, which is, as you see, really mosaic. It's also a good spawning habitat, but the many hectares of spawning habitat I showed you before, it's actually unused by most of the pike. So yeah, so just to conclude with some overall results, both of these studies actually exemplify that the problem we have with many anadromous pike spawning areas in Estonia, meaning that they have become ecological traps for anadromous pike. In Estonia, we think that the main reason for this is river canalization and dredging, coupled with the effects of climate change. As I mentioned, the springs have less water now, so there isn't much floodings happening anymore. And this is bad news for anadromous pike in Estonia and also probably for other pike in other areas in the Baltic. So, and yeah, as we can't do much for the pike in the short run, the only fast solution for improving the pike stocks, at least in Estonia, is to actually construct these freshwater spawning areas or restore these freshwater spawning areas, which are now called the pike factories. So with this, I thank you. I also thank the organizers for organizing this nice symposium, and I'm open for questions.
Thank you very much, Mehlis.